Let me show you the PNID. Okay, here. As you can see, there is a fellow element here. It stands for FE102. I want to do calculation for this item. So in my PNID, I need to write the name of this one. So it's FE102. About the PNID number, you can just, write something. It's not really important at all. For example, 103. And you can just mention about the revision of the document PNID 2. For example, it's just D00. Okay, next one. For case of service, as you can see here, the service of this one is related to the outlet of vessel 102, and this one actually is going to be connected to flare line. FL here stands for flare, so you can just write this item here. This one is gas line from V102 to wind, or you can write flare 2. Okay. Next item is related for line and equipment number. You can just see that this one is gas 005 and 3C 2 inches PT. So I need to write it here. It's just gas 005. So N3C and 2 inches and PT. Okay, about the material and size, as you know that with the help of PMS, we can just fill it up too. So let me just open up my sample project PMS and find N3C inside. That's it. So after that, you can see the class N3C. And as you can see here, for case of pipe, you will be able to find out the material of this one too. I can just, copy this one and put it here for case of the material. And as you know, the size of my line is 2 inches. Next one for case of schedule, which is related to the thickness of the pipe, you can just see that this one is schedule 80. So it's a thing that I can copy here too. And about the class of line is N3C. Okay, after that, here is related for internal diameter. For just reviewing, I want to tell you that when you want to calculate the beta ratio, for sure, this one is resulted from the division of lowercase d divided by capital D. As you know, capital D stands for internal diameter of the pipe. So for case of internal diameter of the pipe, we can just use different types of standard, but for sure, one of the most famous one is ASME or ASME B16.36. So with the help of this standard, you are able to just find out the inner part of your pipe. How? For this item, you need to just have the outer of a pipe, the overall diameter of your pipe, and then you need to have the related schedule grade. Here is schedule 80, and after that you are able to find out the internal diameter. Here I'm going to show you how you can use the table of standard ASME B16.36, and after that how you can find it this one. So please come here. Okay, this is the standard. As I mentioned that before, I need to find out the 2-inch size. As you can see, I've just found it. This one is 2 inches. As you can see, the outside diameter is the real one, is 2.375, and their related schedule is 80. Okay, now you must find out the inside diameter. The column of inside diameter is here, and when I just check it, I found out that it's 1.939. So this is the diameter or inside diameter of my pipe, and I need to just write it here, 1.939. Okay, as you know, this part is going to be filled up with the help of the process engineers. So just imagine I ask some of my colleagues to prepare and fill this part for me. The thing that I've already received is something that I'm going to write. The fluid is gas, and the state of it is gas too. About the maximum of the flow is 774.4. This one is kilogram per an hour. The operating is 704. And for this one, minimum has not mentioned by process engineer, so I can just put it this item, okay? And next one for case of maximum pressure is 14.4 bar absolute, but we need to be careful because this one is bar absolute. Next one for operating is 11.7. After that, we have the temperature, which is maximum of it is 65 and the operating is 40. Now I have the specific gravity, which is 1.83, and then the molecular mass for this one is 53.18. Then I have the viscosity, which is 0.011. Then I have heat specific ratio, or Cp divided by Cv. Here is 1.23.